Assalamualaikum and a very good morning to my lecturer Dr. Azri. Today I am doing one simple experiment, which is option B, that is pendulum system. My goal is to demonstrate how energy transform and forces interact during a simple swing.
For our apparatus, we have protector, a bob balls, a string with measurement, a ruler, a handmade retort stand. Before we start our experiment, we first weigh our bob ball, and the weight indicate 22.03 gram.
So for our setup, we have our own ball, which is our bob, tied to a string with a designated length, and also our own retort stand. We make this from scratch. While it looks simple, but this system is a perfect way to visualize Newton's law and conservation of mechanical energy in real life. So our theta will be around 10 to 15 degrees only. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we measure this 3 times to get the average time.
Let's break down the physics. At the very top of the swing, just before release, the ball has zero velocity. Here its energy is entirely gravitational potential energy, calculated as PE equals mgh. As it falls, that potential energy doesn't disappear, it converts into motion. By the time the ball reaches the bottom of the arc, the equilibrium position height is zero, meaning potential energy is zero. However, this is where the ball is moving fastest. At this bottom point, all that stored energy has transformed into kinetic energy, calculated as Ke equal half mv square. According to the conservation of mechanical energy, if we ignore a resistance, the energy we start with at the top equals the energy we have at the bottom. Finally, Newton's law are constant at play. Throughout the swing, there are two main forces, gravity pulling down and tension pulling up along the string. The result is a net force that constantly accelerates the ball toward the center, creating the swinging motion. By measuring the height we start with, we can mathematically predict exactly how fast this ball should be going at the bottom. Let's look at our data. So as we can see, at length 10 cm, the average time for 10 oscillation is 7.37 seconds. For 15 cm will be 8.76 seconds. For 20 will be 9.98 seconds, and for 25 will be 10.57 seconds. So next, let's break down all the calculation. Before we start our calculation, we list our variable. For our first variable will be the mass, which is 22.03 gram, will be converted into kilogram. That will be 0.02203 kilogram. And our angle of release, theta, will be 50 degree angle. Our gravity acceleration will be 9.81 meter per second square, and our length will be 10 centimeter, which will be converted into meter, which is 0.1 meter. First calculation will be calculate the height of pendulum, which will be using the formula h equals to length times 1 minus cos theta. We key in all the information and our h will be 0.00341 meter. Next is the gravitational potential energy. We'll be using the formula PE equals mgh, and we key in all that information and our gravitational potential energy we will get 0.000737 joule. Our calculation after that will be the velocity at the bottom. Our velocity will be using the formula V equals square root 2gh, and our velocity we will get 0.259 meter per second. Our next will be our kinetic energy. Our kinetic energy will be using the formula half mv square. So after key in all the information, our kinetic energy will be 0.000739 joule. Next is our experimental period. We will be using the formula T equals our average time for 10 oscillation over 10, and we will get the 0.74 second. Next will be calculate the theoretical period. We'll be using the formula 2 pi square root length over gravity. We key in the information, and the theoretical period we will get is 0.63 second. After that, we just calculate the rest of the length and put it on the table. And this is the result of our table. The result show that the experiment successfully verified the fundamental project of the simple pendulum, demonstrating that the period increased with length and that mechanical energy is conserved, as shown by the high accuracy between the potential and kinetic energy value. The gravitational potential energy at the highest point is converted into kinetic energy at the lowest point. The difference in energy and period may be caused by the air resistance, friction at the suspension point, using release angle larger than 10 degree, and human reaction time when using the stopwatch. In conclusion, the pendulum system provides a clear demonstration of Newton's law of motion, work, energy, and conservation of mechanical energy. The experiment successfully validates that the conservation of mechanical energy, evidenced by the near-perfect agreement between gravitational potential and kinetic energy, while also confirming the theoretical relationship that period of oscillation increase with length. This experiment successfully applies theoretical physics concept to a real-life system.